Then move on to the next example. You can try that, right? Just apply the formulas of those things. Right, that for f of x equals arctangent of 1 minus x. I remember the arctangent formula will be u prime over 1 plus u squared. So the derivative of arctangent will be 1 plus u squared. And the numerator will be the derivative of 1 minus x, that's negative 1. So what we have is negative 1 over 1 plus the form x 1 minus x, 2x plus x squared. That's negative 1 over 2 minus 2x plus x squared. Keeping ascending order is also fine. Usually writing polynomial, we write it in descending order, which means power from highest to lowest. But in ascending order is totally also okay, right, to write a polynomial. Right, so I believe in your algebra course, right, at least college algebra course, right, you have seen that completing a square, which is completing from this format into a perfect square with a constant, right? In other words, you have seen that in your pre-calculus as well, right? To get a somehow in the format of what? Of a parabola with a vertex, right? Something like that. I believe you have seen that typical thing as already. Right, we're not required to do those things in our course here, but for the integration of calculus, yes, you need. For your future semesters, yes. You are taking the integration calculus. Right, then the next question is arcsecant of e to the 2x. Right, which we know that the range of exponential function are all positive, right? That I believe was the thing we know. Then we take the derivative, use the effect. F prime of x, the formula is absolute of u times square root of u square minus 1. And the numerator will be the derivative of u. Right? That formula is just written. Right? The fact is the e to the 2x is always bigger than 0 for all x in the domain. Right? For all x. Therefore, the absolute actually we don't have to worry about it. And that we get 2 e to the 2x over e to the 2x square root of the power of power also is the product of power, right? E to the 2x to the second power, is e to the 4x. 2x times 2 basically. And then since the absolute value we can take that out because of the fact, then we're able to reduce it. I reduce the e to the 2x. Therefore, our derivative will be just 2 over square root e to the 4x minus 1. Right, that is the derivative. Right, the next question is a very classic example for y equals or arcsine of x plus x radical 1 minus x squared. Right, arcsine of x is no problem. The other part, x radical 1 minus x squared, we need to take care of it. Right, so start with the term u is x, no problem. V is square root of 1 minus x squared, which is 1 minus x squared to the 1/2 power. Right, therefore u prime is 1. Now v prime is apply the chain rule, right? Negative 1/2 multiply the derivative of inside is negative 2x. That is negative x over square root of 1 minus x squared. Flip the power down and become radical. 1/2 times 2x, get rid of it, the fraction, that will remain negative x on the numerator. Well, that's what we have for the product here. Therefore, f prime of x now is doable, right? F prime of x. That's the derivative of arcsine of x simply. That is 1 over square root of 1 minus x squared. Right, that's the formula. U prime, which is 1 over square root of 1 minus u squared, plus u prime times v, 1 times square root of 1 minus x squared, plus v prime times u. Which is 1 square root of 1 minus x squared plus square root of 1 minus x squared minus x squared over square root of 1 minus x squared. Right, that of course at least we can see they could be combined together. F prime of x will be 1 minus x squared over square root of 1 minus x squared plus square root of 1 minus x squared. That we can also see that 1 minus x squared and the square root of 1 minus x squared have same base. The power is 1 and the power underneath, on the bottom is 1/2. So when we divide them, we subtract the power, we're left square root of 1 minus x squared. It's like u to the first power over u to the 1/2 power. That is u to the 1 minus 1/2, that is u to the 1/2. Well, if we explain that in detail, right, that is first power divided by 1/2 power is the subtraction of powers, remain the new power, which is 1/2, that's square root of u. Same thing as the one we omitted, right, we just analyze it. Then plus the square root of 1 minus x squared, and we see indeed that's twice of square root 1 minus x squared. Right, so in the process that will give us at most 3 terms, but at the end we can simplify into a single term expression for the f prime of x. Right, so how beautiful it is, right, to work. Well, that is this section doing, right? The most thing it does is apply the property of inverse trigonometric function and some functions we have seen, right? So you will see more practice on your homework. Right? More practice on your homework, you will see. Then we go to the last section in this chapter. Section 3.7 is about the related rates. So we use the idea that, well, every variable For instance, the variable x and the variable y are the function of time. Right? Any set of variable, like we may see the height, we may see the volume, we may see something else, are the function of time. Not necessarily we use the x, y as the variable, we could use some other variable, but they are all functions of time. Which originally we see, right, as the implicit differentiation section we see, the y is assuming as the function of x. Right? Therefore, we take the derivative, that rate of change of y is depends on the rate of change of x. Right? But now in this section, the related rates, our variables are functions of times, then a function of time. Also, the variables are somehow related. Then their rates, which is we take derivative of x respect to time, and derivative of the other variable respect to time are related. Right, so that is the basic idea that in our section shows. Right, so basically our variables are changing based on time changing. Then for some wording we can get from the question, the variables are related. Right? Then we take in derivative using the implicit differentiation. This time our variable is time, basically the chain rule. Right? In the example that the function is related to the variable of time, then the derivative we take, the x is changing based on the time, the y variable is changing based on the time, or any variable is changing based on the time, we take derivative of the original equation, we'll see that relationship between the rate of changing based on time. So that is the basic idea in this chapter, in this section. Well, we will see example, then it will be maybe it will be a little more clear of what we mean. And of course, this section you will see most of them are word problems. Right, so this question, right, what we see from that is a conical tank, which is a tank which basically is a cone. Might have a cone shape of tank. Might have the radius 2 feet and the height of the cone is 4 feet. Which that cutting piece or cutting part, right? The cutting part piece is a right triangle basically. Right, what else is, well, the water getting drained out of it. Some part is the water level, and underneath our water is getting drained out of the tank. And the volume, radius, and the height is, all of them are function of time. Right, what we know that is the volume of a cone-shaped container is a third of pi r squared times h. Right, that's what we can find out, right? Even from the online sources or from other places. Right, that's a third pi r squared h. Then the volume and the height definitely are the function of time. Right? By time changing, the volume will remain as different, right? As the variable of time, they have remained differently. Right? And what we get is originally the ratio between height and the radius is 4:2. The ratio between the height and the radius is 4:2, which means the height is twice of the radius for any time remain, right? For the water tank remains, right? For the water remains. Right, that's the second information. Height is 4, radius is 2, so it will hold for even though the water is draining out of the container, right? That relationship will still holds. Then also the second sentence just telling us we find the rate of change. Right, the rate of height decrease is 0.2 feet per minute. Right, since it's decreased, right, it's getting lower. So what we get is the rate, which is the derivative of our height as a rate of time is 0.2 feet per minute as the unit, but since it's decreased, right, our height is originally was 4 feet, then as time passing, 1 minute later will become 3.8, 2 minutes will become 3.6, and so on. The rate is decreasing, that by time passing our height decreases, right? Therefore, looking for the words carefully if that's increase or decrease, right? Since the water is drained out, the height has to be decreased, and then intuitively the volume has to be decreased as well, right? So we will get usually positive number for increase, negative number for decrease. So that's what the information are given, right? And we need to find out is the change of volume as the time changing, right? dV dt, and also given is our height at the time is 2 feet. Right, so actually looks like the radius doing nothing inside, right? Only given the height is 2 feet, the radius doing nothing information over here. Right? So that is everything given. So our volume could be converted to a function of height, since that's everything we care about. And we know that radius is a half of the height. Which we can convert as that's h to the second over 4. That will be 1/12 pi h to the third. Right, that's we're converting. Then we take the derivative on both sides of the equation. Right, dv dt is the rate of change of volume by over the time. Is 1/12. Pi is also a coefficient times 3h squared times our dh over dt. We only have variable of volume and the height in this case, right? That the radius can be converted to height since they are related. Then, which is 1/4 pi h squared dh dt. Right, then we're seeking for dv dt. We're given dh dt is negative 0.2. We're given height is 2. Right, the unit, if you're concerning, that's feet. Right, then we have square of feet. We multiply by feet per minute, which will give us the unit will be cubic feet per minute, which is appropriate for the volume changing. 1/4 pi times the square of 2 times the negative 0.2. 4 over 4 cancels, negative 0.2 pi. The unit is cubic feet per minute. And that is the volume changing. If you multiply, that will be negative 0.628 cubic feet per minute. As the water remain is still 2 feet left. Right? And negative 6.28, which means the volume decreases at the rate of 0.2 pi cubic feet per minute. If you want to write conclusion. The volume decreases at 0.2 pi cubic feet per minute. Right, so the negative shows that the volume is decreased at the rate 0.2 pi cubic feet per minute. Right, so this type of question, right, is nothing else but just analyze the question carefully. That what we will get is what equation we hold, given what information is is the majority part of this type of question, and what to find. Right, then afterwards it's just derivative of the equation. I differentiate it on both sides. Just be careful that using the chain rule properly. Use the chain rule properly, which means every function is a function of time. So we need to apply the chain rule that the volume is a function of time, height is a function of time, then substitute all the given information into our equation. Right, so that requires analyzing the problem. Right, be very careful of the given information. Right, that's the key thing. So, which means reading is a basic skill you need. Right. when a pebble, right, drops into a compound, it will causing some ripples, right, in the form of concentric circles. Then of that circle is expanding, right? The radius of outer ripple is increasing at a constant rate of 1 foot per second. Right? That's what it is. Short. Then asking when the radius is 4 feet, at what rate is the area of the disturbed water changing. Right, so if you drop something, right, to a surface that somehow the water surface, right, the pebble drops into it, drop into the surface, then it will causing some circle expanding at a certain rate, right? The radius and the area disturbed, right, are related, which basically the area of a circle is pi r squared. Right, that's what we know. Right, so let's see what gives. That's the radius is increased at a rate of 1 foot per second. Right, that's what we given. And then at the time radius is 4 feet, asking the radius area changing. Rate of the area changing. Right, so translate into symbols. What we given is the rate of change of radius is increased at 1 foot per second. If we keep unit, that's 1 foot per second. Also, the radius is at 4 feet. Asking for the change of area as the time change. Right, that's given and find. Given which part and find which part. So we know that the formula of the area of the circle is A equal pi r squared. Right, so we differentiate over time, pi times 2r, and the radius is also a function of time. Right, so dA dt equal pi times 2r times dr dt, which dA dt we need to looking for. Pi times r is at 4 feet, dr dt is 1 foot per second. That we get is 2 times 4 times 1 is 8 pi square feet per second. If you want to write conclusion, right, the area is changing at a rate of 8 pi square feet per second. Right, so the harder part is collecting all the information from the question. Afterwards, what we do is they differentiate the equation we get, use chain rule carefully, then substitute all the information and finding the seeking one. Right? Not that tricky, but again, the tricky part is to get all the information from wording and carefully read the question. Right? That's the tricky part from those type of questions. Air is being pumped. into a spherical spherical is balloon at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius Right, so we get a spherical balloon. Right, that's what we have, right? Spherical balloon and attached to some bumper or whatever thing that constantly will get air into the balloon and it will expanding. It will expanding. Right, since that is a sphere, we have a radius and we have the volume. Right, so we know that the volume of a spherical object is pi r, not pi r, 4/3 pi r to the third. Right, that's the volume of a spherical object. Right, given that dV over dt is 4.5 cubic feet per minute. Right, since it's bumped into the balloon, that pumper is just having the air into the balloon. Right, then the rate of change of the air pumped will be the rate of change of the volume. Right, that makes sense. Pump air into that at this rate, that means the volume of balloon is expanding at this rate. That means the volume change at this rate, right, of 4.5. Then we also be given that the radius is 2. We need to find out what is rate of change of radius based on the time change. Right, so do the derivative. Right, the dV dt is 4/3 pi times 3r squared times dr over dt. Which the derivative is of volume change, right? Is 4 pi r squared times the rate of radius change. Then we substitute the given information, right? Given that the dV dt is 4.5, the radius is 2, but we don't know the dr dt. Right, that is 16 pi. 4.5 over 16 pi, which if we multiply by 2, that's 9 over 32 pi. And double check the unit, right? We have cubic feet per minute, we have the constant multiplied by the unit is feet squared, that will be feet per minute. Right, so since the radius is large enough and the volume is not that relatively changing very fast, then we have the rate of radius changing in this time will be very, very small. Right, it makes sense, right? Instantly in the initial, that the radius will change very fast, but as the time goes, as the radius is big, the change of rate of radius will be relatively getting small. Right, so 9 over 32 is about 0.09 feet. About 9.09.